Newton's first law of motion. An object that is at rest will stay at rest unless a force acts upon it. An object that is in motion will not change its velocity unless a force acts upon it. Some definitions you'll be using. Dynamics. The study of dynamics explains why objects move the way they do. In this lesson, we're going to look at measuring forces. The unit of measure that is used when measuring forces is the Newton, represented by the symbol N, and this SI unit of force is 1 Newton is 1 kilogram per meters divided by seconds squared. When measuring forces in a lab, you could either use a spring scale or a force sensor. We use force diagrams to show the forces acting on an object. We could use a system diagram, which is a simple sketch showing the objects involved in the situation, shown in the diagram in figure 2, or we could draw a free body diagram, which is a simple drawing of an object showing all the forces that are acting upon it. This shows the force acting up and the force acting down. We have the hand pulling up and the force of gravity pulling down. So what are some everyday forces? First of all, we have applied forces. These are the forces that result when one object makes contact with another object. I am pushing a book across my desk. Tension is a pulling force from a rope or string attached to an object that always points towards the rope or string. Normal force. This is the perpendicular force exerted by a surface on an object in contact with the surface. The normal force always points away from the surface. Friction opposes the sliding of the two surfaces across one another. Think of you walking on ice, very little friction. Friction acts opposite to the motion or attempted motion. Gravity. The force of attraction between two objects is called gravitational force. Here is an example. In diagram A, we have a system diagram of a wagon and two children pushing and pulling on it. In figure B, we have a free body diagram showing all the forces acting on it. And you'll notice it tells you which force it is. Force of N, the normal force, force of T, force of A, force of T, and force of G. If you forget what these mean, go back to the previous slide. The force of gravity. This is a constant, and it's equal to the mass times G. And G is equal to 9.8 meters per second squared. So you need to know the mass in kilograms of the object and apply the constant for the force of gravity, 9.8 meters per second squared. Now, it's time for you to pause this video and in your reading, Work through tutorial 1 on drawing force diagrams on page 117, then practice the simple problem 2 on page 118. When you are confident you've mastered these 2 skills, please return to this video. Now, how to calculate net forces. Net force is the sum of all forces acting on an object. For practice on calculating net forces, answer the sample problem 1 in your text on page 119. Inertia. Inertia is the property of matter that causes it to resist change in motion. Inertia is proportional to the mass of the object. The heavier the object, the more inertia it has. So that brings us to the first law of motion. An object will remain at rest or continue to move at a constant velocity when the net force, all the forces acting on the object, is equal to 0. A non-zero net force will change the velocity. The velocity can change magnitude or size, direction, or both. A net force is not required to maintain the velocity of an object. External forces are required to change the motion of an object. Internal forces will have no effect on the motion of an object. Now it's time for another tutorial on free body diagrams and the first law of motion. Complete the tutorial on FBD's free body diagrams and the first law of motion given on page 124. When you're finished, answer sample problem 3, determining the missing force on page 126. Then return to this video. It's your turn. Now you're ready to complete assignment 3 for submission. It will use the material covered in this video. Remember, ask your teacher for specific question help if needed.